Here is a limit that involves sine x over x, and you're tempted to use the famous result of the limit of sine x over x being equal to 1, but remember that this is only valid if x goes to 0, not to infinity. If you look at the function that we trying to find the limit for, then we can split it as x over x plus sine x over x. Now, well, this is really 1, and the limit as x goes to infinity is 1, so we need to investigate what this is going to be. That's the limit of sine x over x as x goes to infinity, and you probably intuitively can find out what this is because sine x is bounded between -1 and 1, and x in the denominator is going to a very huge number, so that's a finite number by a huge number that should go to be 0. Formally, this is done using the squeeze theorem, which means that I know that sine x is lower than or equal to 1 and greater than or equal to -1. Now if I divide by x all the way, because x is positive, x is going to infinity, so this is going to be -1 over x is less than or equal to sine x over x divided by is less than or equal to 1 over x. Now I take the limit as x goes to infinity of this side, so that's going to be 0, and I take the limit as x goes to infinity of this, that's going to be 0, and therefore the limit as x goes to infinity of sine x over x is a squeeze between these two limits, which should also be 0. So the result is just only the limit of x over x, and that is 1, and the answer is A. Okay, here is another limit that involves the sine function, and the first thing that may come to your mind again is the famous result, or the limit sine x over x as x goes to 0 being equal to 1. But if you do a direct substitution in this limit, you see that the result is going to be infinity for x multiplied by sine 1 over 2 times infinity, which is 0, and the sine of 0 is going to be 0. So this is just as bad as 0 over 0 or infinity over infinity. Is just indeterminate. So we really need to make some rearrangement of this expression. So that limit, which is the limit as x goes to infinity of x multiplied by sine 1 over 2x, could be written as the limit as x goes to infinity of sine 1 over 2x divided by 1 over x. Well, this looks very similar to the famous limit, except that I have to deal with the 2 in the argument of the sign in the numerator. So if I just multiply, as you will see shortly, 1 over 2x, if I multiply here by 2 and divide by 2, so I can pull the 1/2 out, this 1/2 I mean, and that's going to be the limit of sine of 1 over 2x divided by 1 over 2x as x goes to infinity. Now it is easy to see that if we make this substitution, that w is equal to 1 over 2x, then as x goes to infinity, it is true that w will go to 0, but from the right hand side because x is positive, and therefore this limit can be rewritten as the limit as w goes to 0 from the right hand side of 1/2 times sine w over w, which is obviously 1/2 because the limit of sine w over w as w goes to 0 is just 1. Okay, here's a limit that involves the trigonometric functions, and if you do a direct substitution by 1, then in the numerator it will be tan of 0 divided by tan of 0 in the denominator, and that is going to be 0 over 0, and that's indeterminate. And therefore we need to do something about the expression. If you look at this expression, tan of 3 multiplied by x minus 1 divided by tan of 5 multiplied by x minus 1, you see that I can write the numerator as sine of 3 multiplied by x minus 1 divided by cosine of 3 multiplied by x minus 1, the denominator also as sine of 5 multiplied by x minus 1 and then I have cosine 5 times x minus 1. There is no problem with this part here, because the limit as x goes to 1, this is going to be cosine 0, and that's 1, and similarly this is going to be also 1. So therefore I really have to deal with sine of 3x minus 1 and sine 5x minus 1, which are not really consistent in terms of the arguments. So what I want to do is that I want to create something like a sine w over w. So this is what I will do. This is a sine of 3x minus 1, and I will just divide by 3, and this is x minus 1. So when I do a w as 3 times x minus 1, then I will get to the famous limit of sine w over w being equal to 1. And now for the other expression, which is sine of 5 multiplied by x minus 1, I'll just multiply in the numerator by 5, and then I have x minus 1 here. Now you just can't multiply, therefore then you have to divide also. So you divide this by 5 multiply by x minus 1, and of course you have to repeat this here. Okay, so that's 3 times x minus 1. And we still hold, of course, the cosine of 5x minus 1 here, and down we have cosine 3 times x minus 1. Remember, we're taking the limit of this long expression as x goes to 1, and I'm going to investigate it one by one. So the limit of 3 multiplied by x minus 1, sorry, sine of 3x minus 1 divided by 3 times x minus 1 as x goes to 1. If I just make this substitution, that w is equal to 3 multiplied by x minus 1, then I know that as x goes to 1, then w will go to 0. So this is going to be the limit as w goes to 0 of sine w divided by w, and that's going to be 1. Similarly, then I can do the same thing to this expression here, right? So that's also going to be 1, because that's the limit. Of course, you can put everything in the denominator. So this is 5 times x minus 1 divided by x minus 1 multiplied by 5 as x goes to 1. It will be the same thing if you just make a substitution by w equal to 5 multiplied by x minus 1. So that's also going to be 1. Now, if you look at the last part here, and this part is going to be equal to 1, because as x goes to 1, this is going to be cosine 0 over cosine 0, and that's 1 over 1, so this is just 1. And now it is only left to evaluate this expression here, which is, of course, obviously 3 over 5. So the limit as x goes to 1 of this expression, let me just put it as a circle here. This is going to be simply 3 over 5, because x minus 1 will cancel with x minus 1, and you're left with only 3 over 5. So now this is going to be just 1 multiplied by 1 multiplied by 3 over 5 multiplied by 1, and the answer is 3 over 5. Okay, this is a limit again that involves trigonometric functions. A direct substitution will result in 0 over 0, which is indeterminate. So what I will do is that I will do some manipulations. I will start by expanding the numerator as the famous formula for sine alpha plus or minus beta says. Okay, now sine alpha minus beta is sine alpha cosine beta minus cosine alpha sine beta. So the limit here is going to be equal to the limit as x goes to 0 of sine x to the 4 cosine x squared minus cosine x to the 4 sine x squared divided by sine square of x divided by cosine squared of x. That's the tan, sine over cosine. And I can rearrange this as just by multiplying by cosine, or just bringing the cosine square in the numerator. Now I'm not really worried about the cosines, because as x goes to 0, this is going to be just 1. This is also going to be 1, and this is going to be 1. So the problem is with the signs here, and I really need to do some arrangements because the arguments are not just simply x. I'm splitting this limit into two parts. I will investigate each part separately, and I will investigate the blue one first. Okay, as you can see that this is the limit of sine x to the 4 cosine x squared. Again, there's no problem with the cosine. If I have to make this limit look like sine of w over w as w goes to 0, which is a famous limit being equal to 1, then I really have to adjust the argument. So this is sine x to the 4, and I'll just divide this by x to the 4 so the arguments are the same. I can't just divide, I also have to multiply by the same thing. I still have a sine square of x here, and this is my cosine x squared. Now if you look at this limit again, so this is the limit as x goes to 0. This is sine x to the 4 divided by x to the 4, and that's x squared. I'm taking only two of these, and I'm putting this as sine x over x, and everything is just square. That can be, x to the 4 can be retrieved by just bringing this x down below the sign up again. So this is cosine of x squared. Now I will just look into this limit here, all right, separately, and I say, okay, fine, this is the limit as x goes to 0 of sine x to the 4 over x to the 4. Again, if w is equal to x to the 4, so as w goes to as x goes to 0, we know that it is true that w will also go to 0, and therefore this limit could be written as the limit as w goes to 0 of sine w over w, which is the famous limit, and that's equal to 1. Now we look at this limit here, all right, and this limit is let me just bring it down here. So that's the limit as x goes to 0 of 1 over sine x over x square, and that's going to be equal to 1 over, again we pass the limit inside, so that's the limit as sine x over x as x goes to 0. That's 1, so this is 1 over 1 squared, which is 1. Now let's look at everything together, right? This is going to be 1, yes, and this is going to be 1, and this is also 1, and as x goes to 0, this is going to 0, so the whole thing is just 0. So this first limit is actually 0. Let's now look at the second limit. Okay, the second limit, which is the limit as x goes to 0 of sine x squared cosine x to the 4 divided by sine squared of x. Again, I'm not really worried about the cosine because that's 1. So this is going to be the limit as x goes to 0, and I have to create again sine w over w. So this is x squared. I'll divide that by x squared and then multiply it also by x squared, and this is sine squared x, and that's cosine x to the 4, right? Again, without going into the details again, this is going to be 1, right? If w is equal to x squared, that's 1. Now this is also 1 because this is sine x over x, everything is squared in the denominator, that's also 1, and that's 1 as x goes to 0, cosine 0 is going to approach 1, so everything is just 1. So the result of this limit is going to be equal to, that's a 0 minus 1, and then of course the limit of this is just 1, so multiply that by 1 and the result is just minus 1. Well, here is another way by which this limit can be evaluated. First of all, I'm just splitting the tan squared x as sine squared x divided by cosine squared x, and I'm bringing the cosine squared in the numerator. Now I want to create sort of a sine w over w, and therefore I will just divide by the argument of the sine. So that's x to the 4 minus x squared, and obviously you cannot just divide, then you really have to multiply also by the same thing. Okay, and for the sine squared x, I really need an x for each sine, and therefore I'll just multiply this by x squared and divide by the same thing here. So I haven't done anything here bad to the expression. uh, Now I can tell you now, if you go ahead and evaluate this here, this is going to be 1, because you can assume that w is equal to x to the 4 minus x squared. Then as x goes to 0, w will also be equal to 0, and that's a sine w over w as w goes to 0, and that's 1. And for this expression here, this is going to be the limit, of course, of 1 over sine x over x, and that's a square, as x goes to 0, and that's exactly 1 over 1 square, which is 1. And for the last part here, which is cosine x, this is going to be equal to 1, because cosine 0 is just 1. Now it is only left to evaluate the limit of x to the 4 minus x squared over x squared, which is this part here, as x goes to 0, and this is equal to the limit as x goes to 0 of x squared minus 1. Right, and as x goes to 0, this is going to be equal to minus 1. So you have 1 multiplied by 1 multiplied by minus 1 multiplied by 1, and the result is just minus 1.